Hello, everyone, and welcome to another Würth Elektronik webinar. And we are very happy to do it in cooperation with Renesas Electronic Corporation and Matrix Industries. My name is Markus Eberle, and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar. The topic of today's webinar is energy harvesting, now a real and efficient solution. Our speakers today are Graham Clark, who is working as Product Marketing Manager at Renesas, Douglas Tam, who is CTO and co-founder of Matrix Industries, and Loran Völke, who is working as Field Application Engineer and Business Development Manager at Würth Elektronik ISOs. They will hold today's webinar and also answer your questions. Before we start the webinar, I would like to point out one thing. You will be muted during the webinar today. This means that you cannot ask us questions via microphone during the webinar. Nevertheless, you have the opportunity to ask us questions during the webinar at any time via the chat function. You will find the chat function in the webinar control panel. Today's webinar will be about 30 minutes long. The chat questions will then be answered in a question-answer session following the webinar. There are 10 to 15 minutes in addition scheduled for this. And if we are unable to answer all your questions within this time, we will answer them via email after the webinar. And if you still have any other questions left after the webinar, just email us at isos-webinar@we-online.com. At the end of the webinar, you will be asked to participate in a feedback survey. Of course, we would be pleased if you take the time to fill out the survey and help us to improve our webinars. You will also receive the link to the presentation as well as to the recordings of the webinar only in the next few days. And now I will hand over to our speaker, Lorand, and I wish you an exciting webinar.
Thank you, Marcus. Just a short confirmation. Can you see my screen?
Yeah, Lorand, we can see your screen. Thank you.
Thank you so much. So, hello, everybody. My name is Loran Völke. I'm working with Word over 21 years, and today I will talk about some energy harvesting solutions. First of all, when you think about energy harvesting, I think you have been touched already with energy harvesting. If you just remember your first bicycle, maybe it was driven by the small dynamo to bright your lights when you're traveling by night or when it's dark outside. Or maybe you are still using a desk small calculator which has no battery to change because it's powered from an indoor solar cell. And I guess such kind of water mills or even windmills, if you are traveling in Netherlands or Holland, you will find some of those which is actually energy harvesting as well. But in fact, energy harvesting, normally everybody think this is energy for free, which is correct. But the first thing when you're thinking about energy harvesting, you should not ignore the laws of physics because they are still valid. So you have to find some wasted non-electrical energy. If you find them, and you know which kind of non-electrical energy you are around your device, you can harvest them, convert them with a transducer, and then transform into the electrical energy. This energy is maybe not always used from your device, so you have to store somehow for a time when your device is not working, because maybe this energy form is not always available, and you can recall it just when you need. If you remember the mechanical age, if you are going in a port and you see such kind of buoy with a bell on it, that's from the long time used in the mechanical age when the ship approaching the port and make some waves, and somebody was on the ship and listened with his good ears, and when he heard the bell of this buoy, say to the captain, hey, we are too close to the ground, make few grades on the light, right, left or right, to not running on Earth. And by today digital age, we can have such kind of buoy which is transmitting a very correct GPS location position, and it doesn't need to change any battery because all these stacks have been made in such good efficient way that it's not it's working in very high efficiency, and it doesn't need to change any battery. A special, can you imagine in winter when it's water maybe 1 2 degree and you have to swim there, and to change the battery is not the best option. So that have been done because everything on these stacks working in high efficient and low power, that it can be used the movement of water and the daylight. If you think on our electronic development, I think in the next few years, and it is not approximation for myself, this is um, from some company who make statistic, and they uh, approach that in 2025 we will have more like 75 billion devices connected to each other. It could be just a small sensor like the indoor sensor for um, making your light on or off, a presence sensor for the room, or could be just a temperature sensor. But all that together will be a lot of different electronic small devices, which I think is not the best idea to power that all by battery, even is that low cost. We have today energy harvesting used already more like 20 years in predictive maintenance at the railways. We have in the future maybe few tires where have also built in small sensors for, which is telling to your car, okay, now it's time to change the tire because you're running flat, or you're losing air, or maybe already the tire have too many kilometers to run over and you have to change them. And also we have already today some wearables which using instead of battery your body heat and your movement to give idea about your health, about your condition, and all that is possible using energy harvesting. The current solution to use a battery is not always the best thing. This battery is toxic waste and have also a limited lifetime. If you use energy harvesting, you can, even if you use a battery or accumulator, you can extend the lifetime using the energy harvesting. There are many different small test or I would say development boards where you can try to use this and to make your first steps to use energy harvesting. The first step what you have to do, it is to be aware how your device is working. What is your maximum peak energy? How long is this peak energy? And what is your deep sleep mode energy need? So according to this knowledge that you know exactly how long is your device on and how long is your device's sleep mode, you can calculate the average energy, and you can calculate how to do the storage and which kind of energy harvesting device you can build. The second step, it is to consider different source capabilities. Maybe it is not solar the easiest way, which is almost the first step when you think about energy harvesting, because maybe your device, it will be somewhere in a yeah, under the earth or somewhere where is no daylight at all, but it should work. But then maybe you have temperature difference, so you can use a temperature difference like a thermoelectric generator, or maybe you have vibration, or maybe it is a chemical waste water or something where you can use like electrolyte for your batteries to make a battery from the environment. Much important is to watch over the time how long is this energy there. Then you can make your next step, which is the third step, to choose the right harvester and also to choose the energy storage for the backup when your energy is not available. This storage could be a capacity bank, or you can use super caps. There are now more and more ultra caps, which is a mixture between lithium ion and supercap battery, or you can use even a lithium polymer rechargeable battery. If you look on the new generation of these ARM processors, you can very easily see that um, they are they are much less energy hungry, like maybe 10 years ago. And if you look to the harvester, which you can get on the market, there are more and more energy density is more higher and more capable to generate electricity. If you want to harvest RF energy, well, maybe this is not the best idea because it's just zero point 0.1 microwatt per centimeter square. And this is not always a good idea if you're living close to a mobile phone base station to build a directional Yagi antenna and put a LED on the end to shine with this energy covered and suck it away from the mobile base station. In some countries, like in Germany, it is even illegal because this is not the best way to do energy harvesting. With vibration, if you have a vibration, you can reach 1 milliwatt per centimeter square with the simplest piezo harvester, which is possible to get. With thermal, a good thermal TEG, it can harvest 10 millivolt per centimeter square. The problem is also by the thermal that the voltage is very low, so you need somehow to boost it up because it's starting with very low voltage, but this is possible. Photovoltaic is the most developed and most used technology. So you can already have 100 milliwatt per centimeter square, but there are much more possibility with TEG or by vibration to harvest, like just with a photovoltaic, which uh, is not always available. Würth Elektronik is taking part about European founding project called Symphony. We collaborate with many different companies where new materials are developed and already in testing, and it will be some printed materials um, which will be used for three different applications. One of the application will be predicted maintenance on the blades on the wind turbines. Another application will be smart floor, where it will be detected if the people are working or using this room. And the third one will be for e-bikes. It will be a tube, which give you also by Bluetooth some information about your bicycle tube, and you can know if it's need some air or it is too much air pressure or temperature, whatever, before you make your accident with your e-bike, because with an e-bike today it's quite uh, easy to reach high speed. So this is how it will look, this blade sensor. It will be just sticked on the blades, and it works with vibration and with solar, and it will give information to a gateway about the uh, maybe possible cracks or maybe some predicted failure, and then the company can stop and change the blades, and no accident happen. The next use case is this smart floor, which will be even very useful today by pandemic, like to know how much people are in the store, if the people are keeping the distance, or just know if this room is available because somebody walk on in, can use like alarm system. And every each piece of this wood will be smart, doesn't need battery, doesn't need wires. It will be like a mesh network connecting to each other, and you have just to program once, and then you know exactly what is happening in this room without any battery, just using the human steps working on it. If nobody working, no signal, it's quite really logic. The third use case is that using from the Tubolito, it's a company who make these tubes for e-bikes. It will give you information about the pressuring monitoring and also about the temperature. And he will use also just no battery, just the vibration on the wheel. Of course, you need to make a few steps or a few meters with the bicycle to activate this sensor. and it will be also inside of this tube and doesn't need change. The only one thing what can happen if you, by bad luck you take a nail from the road and it's punching exactly through the sensor, then it's bye bye wheel and bye bye tube and also bye bye electronics. The rest, if it's not that bad luck, you can still make rework it that and you can still reuse it. Companies like Renesas and Matrix, they developed a very interesting evaluation and a demo. This is a nice development where the processor, when it's going in deep sleep mode, it can consume only 100 nanoamp. To measure that, it's very not so trivial. It's quite not so easy. You need a column counter because a multimeter cannot measure nanoamps. And it's a agriculture soil monitoring, which using just thermoelectric and some solar in case you can connect solar and also the thermoelectric. But about that, it will be later discussion from the company Matrix and from the NSATs. The Matrix Mercury 2, it's using the TEG like a source, but the TEG it's providing a very low voltage, maybe something between starting from 5 to 7 millivolts, and this is not enough to move the electrons in the NP junction. Because of that, you will need some small passive components. This is now the Würth Elektronik part, which is a small inductor, or you can call it also transformer, which boosting this current up to 1 to 50 and then start the computer to be powered and then make the management of this power and give it to the output like a controlled energy. How this inductor or transformer looks? Well, if you make a cut, a mechanical cut, you can see on the left picture, this is 1 to 100. The wire what we are using here is the thinnest wire which automat can use. This is thinner like the human hair. And then we put the secondary winding, which is a thick wire. Is that correct? Imagine if I'm telling now some stupid things. Of course, the secondary winding is the thin wire, and the primary is the thick wire, because you boost up the voltage, not boost down the voltage. So the thick wire is not just because we have high current, it's just because to have low losses. On the right picture, you can see the 1 to 50. There are the wire a little bit more thicker in the secondary winding. In the primary is the same. So this is inside how it looks. This kind of small boosting standard component what is need, like if you use a very low voltage, less than 0.6, 0.7 volt, you will need some kind of different boosting transformer. Where is used today energy harvesting? In tracking monitoring from this kind of containers. When the big diesel ship is on the ocean, they have a ground vibration and you can harvest this vibration for months, and then you can know exactly if your container is still there, is transmitting when the supercap is charged a ping and telling to the gateway, yes, I'm here. When the ping is missing after 2-3 days, it means, okay, the container is somewhere lost in the ocean. Plant automation, you can use them in tire pressuring monitoring system. Many car manufacturer already implement kind of energy harvesting, and will be more and more, because to change the tires or the rim just because to access the battery is not a bad idea after every 10,000 kilometer. In an industrial application, I found this company ABB, which make a thermoelectric driven sensor. It's using the temperature from the measurement point and also transmitting in a node, the sensing node, this information about the temperature without battery. Company like Fraunhofer, they developed also a very system on chip where they put a solar cell above a processor where it has also a movement sensor, and it's powered by daylight from indoor light or outdoor light, and you can sense the window, if it's open, closed, or breaking somebody in or something like that. And this is placed inside of this vacuum where is no air between the two glasses, and there's no need maintenance because there's no battery, but it will be also very difficult to change a battery here in this area. We did ask some customer which are using energy harvesting, what was the minimum and the maximum using energy harvester. What I heard, it was the 5 watt, which using solar cells for a meteorological station who was transmitting by GSM. This information from the station, and some other customer give information. The lowest was 50 microwatt and the highest was something by 200 milliwatt using for sensor, self-powered sensors. For 2 years ago, it was on CES in Vegas, in Las Vegas, a company like L'Oreal, which actually everybody knows like a cosmetic industry. They make also sensation. They offer to the people energy harvesting sensor, which you can just stick it on your fingernail, and using a UV LED like harvester, harvesting energy from the day solar light, and memorized in the small chip how much UV light you get during the day. And on the afternoon, you can take your mobile phone and using NFC, you can read out all this data and you can decide which sun blocker you should use next time or next day. Or you can do that also during the day if you are using your mobile phone to power the chip and read out the data. But the sensor himself running just by the UV light. Another nice project, which is driven Professor Roger at the University excuse me, of Chicago in Illinois. They developed with his team a mesh which is directly woven on the heart, and they make some very, very promising tests with um, pacemaker where no battery need inside to be powered. Only just the heartbeat is powering the pacemaker in the future. Also some nice project on the skin. You can see here on the bottom. This is a tattoo or whatever you can say, a sticker, which using solar sensors and temperature sensors, and counting, also making even EKG and also body temperature measurement, and many different measurement which can be used with a mobile phone later instead of using a smartwatch or something like that. And the last product that I found, it was a very funny guy from Brazil. He did make a snoring harvester. So it doesn't take the airflow because it will be not so funny if you sleep to cut away the air, but he's harvesting the snoring, and you can charge your mobile phone with your noise which you're generating, and you will not make much noise for the ambient people. Anyhow, this guy is very funny, but he did receive the Red Dot Award for that. So never knows where the energy harvesting will go.
Good afternoon, everyone. My name is Douglas Tam, and I'm co-founder and CTO of Matrix Industries. And welcome to the Matrix segment of this energy harvesting technology webinar. And I'll be introducing our technology and how Matrix will enable a new generation of always-on devices. So the number of connected devices has been increasing at an exponential rate, and it's primarily driven by growth in the Internet of Things in the past 10 years. Now, many of these devices are powered by large capacity batteries, and with ever larger and far-flung deployments of such devices, it will become less and less practical to rely on batteries alone. So imagine the downtime incurred by battery replacement or recharging, as well as servicing and upkeep costs required to maintain devices. And so it's clear that we will need to employ energy harvesting for a true solution. So today, we have decades of advancements in circuit design and device development to thank for reducing the power requirements of compute and sensor elements. Now, at the same time, energy harvesting capabilities have continued to expand and improve. With any energy harvesting technology that is reliant on the environment to produce power, we often hear concerns about power reliability, especially for devices that need to be always on. So these are questions like, will the harvester continue to supply energy under different conditions? Or can it supply enough current to support a burst in power consumption? Will it fail after 10 years? To address these concerns, we see applications integrating combinations of energy harvesting modes. For example, thermal with solar or thermal with RF. At the same time, energy storage elements with improved cycle lifetimes, extended operating temperatures, and reduced leakage are being deployed. So we are on the verge of creating a new generation of devices that will rely on energy harvesting as a source of power to complement or to replace battery storage. So Matrix Industries was founded in 2011 to realize this vision for energy harvesting. We're based in Menlo Park, California, and comprised of a team of experts spanning fields as diverse as material science, thermal engineering, chip design, product development, and manufacturing. We've got over 40 years of combined experience creating and delivering leading-edge technology. I'll be introducing our technology in the following slides. So our technology stack is really built around Matrix IP and advanced materials and chip design, as well as our know-how in thermal engineering and firmware implementation. So in the lower left corner are our Gemini thermoelectric generators and Mercury boost converter chips, which are integrated into our Prometheus family of energy harvesting modules. Now, Prometheus will be instrumental in bringing our thermal energy harvesting technology to the mass market, and it's the core offering that we will be discussing in the following slides. Now, in the middle here are the Prometheus EVK kits, which are thermal engineered reference solutions for energy harvesting applications. Now, each kit contains a companion heatsink and a mechanical housing for Prometheus, and an engineer can use the kit as an example design to build their own applications. Finally, at the upper right are some examples of applications that include our expertise on low power algorithms, which we won't be talking about today. So how does Prometheus work? The conversion of energy to heat from heat to electricity relies on the Seebeck effect in thermoelectric materials, which states that a voltage difference is created across a material exposed to a temperature gradient. Now, a good thermoelectric material needs to be both a good conductor of electricity and a poor conductor of heat. So this combination of properties is actually quite rarely found in nature. At Matrix, we engineer nanostructured materials that preferentially impede heat flow without affecting electrical conductivity. What I like to use is a traffic analogy when describing this nanostructured material. So imagine a roadway upon which we have strategically placed traffic cones at some fixed distance apart. Now, with the right spacing of cones, the electrical carriers represented by motorcycles can move quickly along the road with minimal deviations from a straight line path. Now, on the other hand, the heat carriers are represented here by trucks have to follow a slower meandering path through the field of cones. So in this way, a thermoelectric generator can supply an electrical current between its terminals whilst maintaining a temperature difference across its faces. Now, Gemini Tag is integrated into every Prometheus module. So a TEG outputs high current at relatively low voltage. And so in many energy harvesting applications, this voltage can be as low as tens of millivolts. Now, as mentioned before, this is insufficient to directly power electronics. And so a boost converter is needed to raise the voltage to suitable levels. Key parameters of interest are cold start voltage, which is the minimum voltage required to start the boost converter from the off state, and the operation voltage, which is the minimum voltage required to sustain boost converter operation. The Prometheus module contains a Mercury boost converter chip, which boasts cold start voltages as low as 16 millivolts and operation voltages as low as 12 millivolts for a true microwatt level operation. Mercury's synchronous boost design also achieves up to 80% peak conversion efficiency and exhibits high efficiency with near ideal input impedance matching across most of its operation window, in contrast to other alternatives Regulated output voltages can be chosen between 2 to 5 volts and can be used to directly charge a battery or to supply the application circuit via a capacitor. Input voltage monitoring with the built-in ADC enables true shutdown and input protection features, and also allows the chip to report instantaneous input power to an external microprocessor. So we have a second generation Prometheus 2 energy harvesting module that includes the Mercury 2 boost converter chip. Like Mercury before it, Mercury 2 improves upon the Mercury boost converter by adding an ability to harvest energy from input voltages of either polarity. Right, so the chip automatically detects and adapts to a changing input polarity and is able to start from cold start voltages as low as 16 millivolts of either polarity, right? And continues to operate down to operation voltages of plus or minus 6 millivolts. So similar to Mercury, Mercury 2's bidirectional boost converter design achieves up to 80% peak conversion efficiency, near ideal input impedance matching, and high efficiency across most of its operation window. Mercury 2 also supports regulated output voltages between 2 to 5 volts and also monitors input voltages for both polarities with a built-in ADC. So the question is, which matrix solution should you use? The answer depends mainly on the nature of the temperature gradient. If your application provides a temperature gradient that's consistently in one direction, use Prometheus. Examples of such applications include wearables that harvest energy from body heat, or sensors powered by heat from the equipment being monitored. Now, on the other hand, if your application encounters a temperature gradient that frequently changes in direction, consider Prometheus 2. Right? Examples include instruments powered by day to night temperature swings in the environment, or devices that need to be powered when encountering temperature gradients of either polarity. So the Prometheus solution integrates a TEG and boost converter into a single ready-to-use energy harvesting module. Because the TEG and the boost converter are perfectly impedance matched and tuned for each other, Prometheus starts off from a temperature difference as small as 0.5 degrees across its faces, throughout the entire operating temperature range of -40 to +85 C. Only two key parameters are required to determine which Prometheus part to use. First, the thermal resistance of the heatsink mated to Prometheus, and second, the desired regulated output voltage. Standard offerings are 5.1 millimeter thick, come in 3 different sizes, with custom shapes or sizes available upon request. Prometheus units with the same output voltage can be connected in parallel for increased power output without needing additional components. Simply add a heatsink and attach Prometheus to a heat source to start harvesting thermal energy, without having to worry about issues like TEG selection, booster layout, and mechanical integration. Use Prometheus in wearable devices, industrial process monitors, and waste heat energy harvesters. Prometheus 2 integrates a TEG and bidirectional boost converter into a single ready-to-use energy harvesting module. Again, by matching the TEG and the booster, Prometheus 2 starts out from temperature differences as small as plus or minus 0.5 degrees C between its faces, across the operating temperature range of -40 to +85 C. Now, as before, only two key parameters are required to determine which Prometheus 2 to use: the thermal resistance of the heatsink and the regulated output voltage. Standard offerings are again 5.1 millimeters thick, come in 2 different sizes, with custom shapes and sizes available. Now, similarly, Prometheus 2 units with the same output voltage can be connected in parallel. Add a heatsink to Prometheus 2 to start harvesting thermal energy. Use Prometheus 2 in remote unattended devices, building and infrastructure monitors, and diurnal heat energy harvesters. So to further accelerate application development and enable rapid prototyping, Matrix also offers development kits for Prometheus and Prometheus 2. These EVK kits contain a companion heatsink and a mechanical housing for Prometheus or Prometheus 2. Each kit provides a complete mechanical assembly to attach the heatsink to an energy harvesting module, as well as convenient mounting points for the desired application. For example, the flat surface kit is used for harvesting thermal energy from surfaces, provides bolt holes for use with non-magnetic surfaces such as aluminum or brass, and 2 magnets for use with magnetic surfaces like iron or steel. Other kits are available for harvesting thermal energy from the wrist, from the upper arm, and more. Each kit contains room for an accessory board with an output connection, and we provide a variety of accessories to support development. For example, a breakout board connects to the energy harvester outputs via spring-loaded pins, and is an easy way to route the output from the module via cable. A blink board can be used to give a visual indication on energy harvesting by blinking an onboard LED whenever there's sufficient energy. Now, outside the kit, a proto board can be used to provide a small surface for prototyping simple circuits, or as a means to connect to the end application circuit. Plans for the kits and accessories are available and can be provided for the engineer to design or fabricate their own parts. Oops, sorry about that. So just to summarize, Matrix is ready to play a role in eliminating your battery problem. Matrix Prometheus family of energy harvesters will power millions of devices, remove the need to replace or recharge batteries, and enable true unattended operation for remote sensor deployments. And we look forward to powering applications in fields as diverse as infrastructure monitoring, industrial sensing, smart agriculture, healthcare, and more. Now, contact us to learn more about Matrix energy harvesting technology. Now, a big thank you to our partners at Würth for organizing this webinar. And I'm going to hand back to Graham to continue his presentation. Thank you for your time today.
So good afternoon, everyone. My name is Graham Clark. I'm the product manager at Renesas, responsible for the RE family, which is our new family of microcontrollers. Also, low power devices are really suitable for energy harvesting applications. And the guys at Würth have asked me to come along today to tell you a bit about what Renesas is doing and the kind of devices we have and the kind of applications that we're seeing for energy harvesting. So I hope in the next 15 minutes I can give you an idea of what Renesas are doing. So as I said, my name is Graham Clark. I'm responsible for the RE microcontroller family. For those of you who are not familiar with Renesas are one of the world's largest semiconductor companies. We're actually the world's largest manufacturer of microcontrollers, and we make many different devices based on ARM core and also our proprietary cores. But today I'm going to talk about our RE family. This is a new family of devices we introduced a year or so ago, aimed specifically at ultra-low power applications, using a unique process technology called silicon on thin buried oxide, which is really designed for the next generation of ultra-low power IoT sensor devices and wearable applications. The nice thing about this technology allows us to create microcontrollers, in this case based on ARM Cortex cores, which offer a unique combination of features. It allows us to offer devices that have ultra-low power consumption, both in active mode and in standby mode. The process is unique in allowing us to operate with very low power consumption in all the modes of the device, and also with very high speed, while at low voltage as well. So with the ARM Cortex core, these devices can run up to 64 megahertz if needed, and they can run down to 1.62 volts while running at that speed. And so it's quite a unique set of characteristics in this very special process. The family are really designed for very low power applications. So we've designed a whole range of ultra low power peripherals for these devices. Today we're talking about energy harvesting. And one of the key peripherals in these devices is we actually implemented a dedicated energy harvester controller on these devices. This allows you to directly implement interfaces to various energy harvesting sources, things like a solar cell, or as Douglas will talk about later, the thermal generators. And the energy harvesting controller will actually allow you to easily control these power sources and actually also manage external power reservoirs, for instance, batteries, perhaps. These devices also have a range of very low power consumption timers. Some of the timers will run as low as 30 nanoamps and allow you to waken up the device or count or make some specific timing. And also we have a range of other low power protocols. One that's very important and I think is really useful is the A to D. The A to D converter in these devices is quite unique and can operate, the whole chip in fact can operate down to 4 microamps while the A to D converter is actually running. Sample around about 1.2 samples a second, with the chip only taking 4 microamps. Ideal for a lot of ultra low powered or even energy harvesting IoT. Security is also important on these devices. So Renesas has their own unique security IP, something called trusted secure IP. And this is effectively almost a secure element, but integrated on the device. So much lower cost, much easier to use. And the one implemented in these devices supports everything for an IoT sensor. It supports encryption acceleration for AES. It supports random number generator. It supports key management, key security. Supports things like secure firmware updates and also secure. So there's a lot of security functionality built into the device.
This is a unique technology by Renesas that we developed over the last 7 years that uses a different type of transistor, a different type of gate on the device, which allows us to offer very low power consumption. So these devices are really optimized for very low power operation, both in active mode and also in standby mode as well. So this type of transistor allows us to offer devices with run currents as low as 12 microamp per megahertz if we use an external DC to DC converter, or if we use an internal power supply in the chip down to about 25 microamps per megahertz. This means we can run our devices at 32 megahertz and consume significantly less than 1 milliamp. So this is really ideal for a lot of applications, either where you want very long battery life or you want to actually use energy harvesting power sources. This is a really unique technology from Renesas. And we've actually been able to prove how useful this technology is. Hopefully many of you are familiar with the Embassy benchmarks. They're most famous for the CoreMark benchmark, but also they have some ultra low power benchmarks, the ULP benchmarks. And there they actually independently verify low power devices running very specific algorithms and actually allow you to benchmark them to see the comparison between the different technologies. The benchmarks typically spend a lot of time in sleep mode, so benchmarking the standby modes and the low power modes, and also waking up, do some processing, run some very specific algorithms, and go back to sleep again. And actually our RE family, based on the silicon and thin buried oxide process technology, actually came out as one of the best devices. We actually achieved a benchmark score of 705. You can find that on their Embassy benchmark pages. And this is typically 50 or 60% better than most of our competitors using standard silicon technology. So this really shows that the RE is based on a very advanced, very low power process technology. We've released a number of different devices on this technology already. This is a typical device that we aim at IoT sensor applications. It has 256K of flash and 128K of RAM. So it's very integrated in terms of memory functionality, has a very high RAM count to allow you to integrate a lot of algorithms and do a lot of data processing. Because in a typical IoT application, there's normally a radio or some communications device, and we want to keep that off for as long as possible. So we want to store data locally. We want to do all the processing locally. We have the very low power A to D converter. If you run the device off the 32 kilohertz clock, the whole chip will consume about 4 microamps while the A to D is converting, and you can convert up to 1600 samples per second in that state at full 14-bit resolution. So for many applications where you want to sample temperature or some other slow-moving physical parameter, the A to D converter is ideal for that. And as I mentioned earlier, we also have a number of timers. We have real-time clock, some very low power 16 and 32-bit timers, and many of them consume currents in the order of nanoamps. So really, again, ideal if you want to have a very long wake up or very low power consumption counting. These timers are ideal for that, which many IoT applications want to do. We also support some wearable applications. So for instance, we support a memory and pixel LCD interface. Memory and pixel is a very low power static LCD technology. So here, these devices, they will take 2 or 3 microamps while actually displaying, and down to under a microamp if you're not actually changing the display for a small graphics interface, so extremely low power. And of course, at the bottom, you can see our energy harvesting controller. And this is really one of the key features that we have on this device. It allows us very easily to integrate various energy harvesting power sources and control the energy that we're harvesting there. And this foil actually shows the kind of function that we have on the energy harvesting controller. It's designed to allow us to, as easily as possible, connect various energy harvesting power sources. So for instance, solar or photovoltaic cells. So tags like the one Douglas has described can easily be connected to this device. And one of the big advantages of the energy harvesting controller is it will actually allow you to start up from very low powers, very low amounts of current. So typically with some of the harvesting technologies, you might only have a few microamps available at, say, 3 volts. And these devices actually allow you to start up from that very small amount of current. A typical microcontroller, when you start it up, when you release reset, will quite often take some milliamps, which can easily destroy the power source, especially if you're using an energy harvesting source. These devices can start up from a very small amount of current. And the way we actually do that is we store the energy in a temporary storage capacitor. You can see here on the right-hand side. And we actually store enough energy, we monitor that capacitor and we store the energy there until we actually have enough energy to actually run the device. So the device, when it's actually booting up, will take the power from the temporary storage capacitor and not power from the energy harvesting source. So this allows us to start up very reliably and also allows us to start up quite quickly as well. The other nice thing with these devices is the energy harvesting controller can also help you manage that energy. So we can also have a secondary energy storage, whether it's a supercap or a rechargeable battery or wherever it might be, and we can actually manage that as well. We can charge it up and we can store energy there and then release it to other devices in the system and to the microcontroller itself when we actually need to do that. So we can take the energy from the thermal harvester or from the photovoltaic cell, we can put it into the temporary storage device just to start up, and then we can start to charge the secondary storage, so the supercap or the battery, store energy there, and then supply it to external devices like radios and sensors when we need them. And that's very typically what we do in a lot of applications. So here we can see a typical application that we might see from many of our customers. This is a typical solar cell based harvesting system. So for instance, in this device, you can see we have some sensors, we have accelerometers, we have some humidity and temperature sensors, in this case from Renesas. We also have some air quality or some gas sensor, again from Renesas. And these devices can actually be powered just from the small photovoltaic cell and using our energy harvesting controller to store that energy and actually release it when we want. So the device will actually store and manage that energy. It will basically allow you to build up the energy in the storage and then release it to power up the sensors and to power up some sort of radio and any other devices that you might have on the board. In fact, our microcontroller can supply up to 30 milliamps directly to external devices, or we can actually use it to switch large amounts of current using external power switches. And as you can see here, we're working with a range of different suppliers for things like a solar panel and photovoltaic cell, who offer us different types of technologies, optimized for internal use, for internal light sources, optimized for solar light sources, optimized for flexible technology. So for instance, from Dracula, we can get a printable solar material that you can actually put on flex. You can print it onto plastics. Lightricity actually provides us with very small devices that are extremely efficient for indoor lighting technologies. So there's a whole range of different technologies that we can use working with our partners in such applications. Another typical range of applications we see is working with companies like Matrix and with the Prometheus modules, as Douglas has described. The tags typically we see in some industrial applications, anywhere where there's a nice heat source that we can actually use. Smart agriculture is another one. We work with Matrix to create something called the Power Spike, which is great for agricultural systems. It's a piece of metal you can drag, you can stick in the ground, and that can actually take energy from the temperature difference between the subsoil, about 50 centimeters under the earth, and the air temperature. And that's enough for us to supply all the electronics. So here you can see, again, a very similar device to what we saw before in terms of the architecture, but now powered by a thermoelectric generator. And this is very efficient for applications where we have some heat source, and we can create a differential from the heat. So as Douglas described, this can work from very small temperature differences. So again, it's quite a common application for things like machine monitoring, for smart agricultural soil monitor systems, for vital sensors, for heart rate monitors, and things like that. Again, other typical application areas might be for structural monitoring, for monitoring of machines, railways and bridges, where there's actually some vibration. And we can actually generate energy from that vibration itself. So we can actually not only sense the vibration, but we can take energy from it to power our devices. So here we're working with a range of companies around the world. So in Europe, we work with a company called Kinergizer, who actually have a vibration harvesters that we can connect to our devices. We need some external electronics in this case just to change the voltage that's generated to a DC voltage that we can use, but we can feed that into an energy harvesting controller, and again we can work to actually take this energy and do useful work with it. And we see many applications for this, particularly in things like railways and machines. So there's a lot of different applications that we can see that are very easy to implement with these devices using different types of harvester. And here's just some of the applications that you can find in the market today. Actually, the first customer of ours last year that announced a product was actually a wearable customer. This was Casio, who are using our devices with very small solar cells. You can just about see on the left-hand diagram at the top of the watch strap, there's some very small solar cells. And the RE has been chosen as the main controller on these devices, working with the solar cells to increase the battery life of these products. We're also working with companies who are making smart taps and water flow devices, where actually they take the power from a very small microturbine that's in the water flow. So when you turn on the tap, you can actually generate energy that charges up a supercap or a battery, and then we can use the electronics to actually control the flow of the water. And we see that in integration systems and in the contactless tap systems for bathrooms, especially important today in the COVID world. We're also working with companies who are doing things like location trackers, so GPS systems. You can even power some quite power-hungry devices like MBIT modems and GPS chips with energy harvesting, as long as you don't want them to run continuously. And we're working with companies who want to track parcels and want to track things like flowers. Again, we're working with some large industrial companies for things like bridge monitoring applications and soil monitoring. Companies like Sharp are producing some very integrated solutions for that. Again, as I mentioned earlier, indoor and air quality monitoring is becoming a big application. And there, Renesas not only have the RE family, we also have air quality sensors as well. And actually, we do now have Bluetooth devices in our family, and we're also working with partners who are making Bluetooth modules. And there, for instance, we're working on battery-free beacon applications. So one application is an emergency device. That if you have an emergency situation, you hit a button, we can actually use an energy harvesting switch that generates enough energy just from hitting the button to actually generate enough energy to actually power the whole system, including the Bluetooth radio, so you can send an emergency message. So there's a lot of different applications actually using energy harvesting in that way. I mentioned already, we have many different partners around the world with many different types of technologies. If you go to our website, you can see videos of many examples of these working with Matrix and with other companies who actually produce solutions that can easily be integrated to our devices. And the RE really provides the glue that connects all these different devices together, whether it be harvesting power sources, whether it be sensors, or whether it be other components like radios. So we have a wide variety of partners. And actually on our website at www.renesas.com/RE, you can find a list of many of these partners who actually have example applications and devices for using with the RE and energy harvesting. Just to finish, I wanted to talk a little bit about our evaluation board. It's something that a lot of people find very useful. Renesas always provide evaluation boards for our microcontrollers. For the RE, we provide an evaluation board that has all the standard components you would expect in a microcontroller evaluation board. There's a debugger interface on chip. There's a J-Link debugger on there, so you can connect your PC, download code. You can single step, do all your debugging there. But there's two unique features of this evaluation board that are very unusual. The first is the evaluation board is designed to allow you to try energy harvesting. So the evaluation board, it comes with an energy harvesting source. In this case, it comes as a small solar cell. And also there's a supercapacitor on the board. So it's very easy for you to actually try an application with energy harvesting. And not only can you use the solar panel, it's very easy, for instance, to connect a matrix tag onto this board as well and actually try that. Also, because many people aren't familiar with them, the board also comes with a small MIPS display as well, so you can try zero power displays with these devices as well, because it's quite interesting to see how low power they are. These evaluation boards are available today in mass production, and they're available from Renesas and all our distributors, including people like DigiKey and so on. So hopefully that's given you a very quick idea of the RE family. Sorry again, we had some technical problem, but for more information about the RE family and what we're doing with energy harvesting, please visit our website at www.renesas.com/RE. And hopefully there you can see a lot more information, all the documentation, as well as videos, examples, and information about what our partners like Matrix are actually doing. So again, thank you very much for your time. I hope this has been interesting, and I think probably we have a very short amount of time to actually answer any questions that you might have.
Yeah, so thank you, Graham, Douglas, and Loran for your interesting presentations. Yeah, Graham, as you've mentioned, now we have also time for your questions. You can just send us the questions with the chat function in the webinar control panel. And if we don't have the time to answer them now, we will answer them via email afterwards, so you will get your answers. So then we will start with our session. Douglas, I think I see a question.
That's right. Yeah, so I think the
you.
first question was, what's the difference of the Gemini TEG and a Peltier element? And the answer is that they are actually very similar. The Peltier devices that you can buy online or find online, they're generally optimized for cooling applications. The TEGs are generally optimized a little bit for the generation aspect. So what we've done here is to have the integrated TEG elements, obviously optimized for generation. Second question was, is the Mercury 2 IC also usable for other energy harvesting applications other than using heat as an energy source, like micro PV cells or vibration? And do you plan on creating a standalone version of the boost converter, which works at an input voltage of down to 16 millivolts? So the first part of the question is that for micro PV cells, it is possible to use a Mercury IC. The caveat is that generally we don't see this being I guess a differentiator in that regard. As for the vibration aspect of it, we do have a solution for vibration, and it's not one of the ICs that I've mentioned. It's actually a Mercury 3 IC that's still we're still developing the transducer for it. But certainly, if there's interest, please reach out to us directly. And then the second half of the question is, do you actually plan on creating a standalone version? We did have a standalone version. The issue was that the integration of that with transducers is not straightforward. And one of the struggles we've had was working with end customers who were trying to integrate it. It just wasn't working out. So we actually took the next step and integrated the transducers into the Prometheus modules that you see today. And I think that's been much more fruitful. And so feel free to reach out to us directly if you have particular applications in mind. But our focus here is on creating the full solution, providing the full solutions, and actually meeting the needs of our customers directly.
Okay, Thank you, Douglas, for your explanation. Then I think we can go on. Graham, there is a question reaching out to you. Just reading the question, are the partner solutions available for purchase? Example, the RE01 and sensor board RE01. Yeah, sensor board POC.
Yeah, that's a good question. Actually, at the moment, they're not generally available for purchase. We only have a few, and they're not CE marked. So there's not something we can actually sell. But actually, we are currently turning a lot of these proof of concept designs into application notes with a list of products that you can buy. So for instance, some of our latest sensor boards now, we're providing a parts list so you can actually buy the component parts to make the equivalent circuit based on our evaluation board. So for instance, the first example of that, we did a LoRa-based design last year, which some customers have been using. But we got a lot of people asking us to buy that. So what we've actually done is a few weeks ago, we published an application note which describes the various component parts. So for instance, a Semtech Arduino shield, there's a Renesas, a sensor module board. And if you buy the component, you can actually build up your own sensor board. So that's the way we're actually managing that at the moment. I hope that answers the question.
Okay, so thank you, Graham, for your explanation. Then I think there are no questions left. If you have any other question, you can also just email us after the webinar at isis-webinar@we-online.com. So, okay, I see there are some questions coming in. So if you know.
Well, I will take a stab at this. I think the question is capacitors for storing harvested energy are often critical parts draining themselves by leakage currents. And are there any suggestions for well-suited parts? And often the data sheets do not talk about that. That's indeed correct. In our experience, the data sheets are very sparse. Certain brands do put out some more detailed information. So I'm sure you're aware. And it comes down to just testing by yourself. In my experience, my personal experience is that MLCCs can be quite good for these, as long as you pick the right MLCC. It's quite sufficient. Of course, the downside is an MLCC capacitor is very small in actual energy density. So then you start to talk about things like super caps, which are very leaky, tantalum caps, which are also quite leaky. So then in my personal experience, the next level is usually a battery, and for these lithium-ion batteries tend to be quite good, good energy density, as well as good leakage, and well, good self-consumption. And so this is where Prometheus can actually directly charge either a battery or a capacitor. I don't know if Graham has any input here. Feel free to chime in.
Yes, thanks, Douglas. Actually, I would just reiterate exactly what you said. What we've found, we've done quite a few designs using different types of radio, different types of sensor that have different demands on the circuitry. And what we've found is, yes, a lot of data sheets a lot of the devices that are available aren't so well documented. And actually, every time we've had to do some testing to understand what the best solution is. We have actually found that some of the suppliers are very helpful in some cases, but we found in every case we had to do some testing once we could narrow down to a range of devices or a range of values, and then we actually test them to see which were best. So certainly what we've found is testing is very important. We just finished a design a few weeks ago, and we had to do quite a lot of testing to understand the right device. And I don't think at the moment there's any way to avoid that. It's the recommendation is different for every design we've done, depending on the characteristics of how long the cycle time is, how long we have to keep a charge, how much energy we need to supply at a particular time. All these things go into it and result in a different device. So I hope that helps.
Yeah, and then I think there's another question here about energy harvesters for EVs and HEVs. I don't think I can really answer that. I think for what it's worth, the energy harvesters matrix is focused on are on the lower end of the power levels. I believe EVs and HEVs, you're dealing with kilowatts, right? So we're certainly not in that business. I'll leave it to perhaps Laura to answer part. I don't know if you
Douglas,
want.
it depends what you want to harvest, because if you want to harvest some temperature, you can use your Prometheus and harvest this temperature from breaks or from the frequency generators, and use that like a sensor. So this is
Yeah.
also energy harvesting, but
So on that
not
note, that's a good point, Laurent. On that note, I think we're not restricted to EVs or HEVs. I suppose
exactly.
any kind of vehicle where we can harvest motion or heat. This is where we would be able to do. Go ahead.
And on low power. So we talk about energy harvesting here in low power. We don't want to make a solar plant or something like that. And this is everything based on sensors and low power devices. By the way, there are some ultra caps called ultra caps, or hybrid batteries, like somebody mentioned Xidas. They get more and more in the market in the future. This is kind of mixture between a supercap and lithium polymer battery, and that could be a good breakthrough for energy harvesting developments, because just it's not maybe always the best option to charge a lithium ion battery alone. So there are some solutions on the market already.
Okay, so thank you all for your explanations. So now we are also finished with our webinar. If there are any questions left, then just email us at isis-webinar@we-online.com. So thank you very much for your attention, and I hope you enjoyed our webinar. Also, big thanks to our speakers, Graham, Douglas, and Loran, for this great webinar.
Thank you. Thank you all. Thank you very much.
Thank you very much for your time.
Yeah, so I hope you will hear us at our next webinar, and I wish you a good day. Goodbye.
Bye-bye.
Bye.